Hey guys, welcome back to another video. It's me, Roland, your tutor from Think Brainwave. In this particular video, we will continue our development from trigonometry in terms of special angles and then on towards developing the cast system where you've got the cos angles being positive in the bottom right hand side of your set of axes, all being positive in the top right, sine only being positive top left, and then tan being positive in the bottom left. In this case, we will be doing ratios in the Cartesian plane. We'll be starting off with a point P with the x value being -3 and the y value being 4. We place this on a Cartesian plane and we will have to start measuring in terms of y, x, and r. So ratios come up quite frequently in grade 10 math, but especially frequently when you get into statistics. So it's very important that you get these sort of core basics down so that you understand what you're doing in other subjects or in other topics later on in maths. So let's look at a plane with an origin of 0. The angle that we will be dealing with is theta. So theta is the angle between the line O and P. Now we're using the point P, so the O must be the origin and P is the end point. And we'll be using the positive x-axis. So we'll be starting, I guess, in the first quadrant. If you think about it, that has to be where the x-axis is positive, because the left-hand side is where x-axis is negative. So now let's calculate our angle theta. What do we do? Our first step. Well, let's look at cos theta. Okay, cos theta, if you look at sine, we go shade your rear, cos x-rays, tan your exterior. So if we've got cos theta, we say cos x raised, so it's x over r. Over here, you only have a -3 value. You don't have the r value. So we need to plot the point. What we're being asked to find out is cos theta, and the other question is 3 tan theta. So as long as we can find our x, our y, and our r, we'll very quickly find these two, the answers to these two questions. So we've got cos theta. I think it's time that we start with step 1. Step 1, what are we going to do? What do you think? Take a guess. If you're working through this at the same time as me, you need to take a guess and go ahead. So we need to sketch the point. The point that needs to be sketched is P, and you have the value above. Let's draw a set of axes. And once you've got that drawn, we can put our point P in. If you're unsure how this all works, make sure to go and check out all the videos before this, because this is all following suit from the first video all the way through this, which is the 13th video of the series. Everything starts off from basic stuff, and it gets a little bit more difficult every time, but it's actually relatively simple as long as you've gone through each and every video. That all makes sense if you add them up from the beginning. But if you just jump in randomly, it's going to seem like a very difficult set of maths to do. So we are saying that our point is actually in the second quadrant. And why is that? Well, as much as we said let's use the x positive axis, our point is -2. So we've got an angle theta that revolves around from the positive x-axis all the way around to the radius of our line. My mistake, it was -3 and 4. So you've got -3 along the x-axis and you've got +4 up the y-axis. You know that once you drop your line or your dotted line down from your point to the x-axis, that dotted line meets at 90 degrees. If it didn't meet at 90 degrees, you wouldn't be able to use either Pythagoras nor trigonometry to fix this situation. Well, especially the type of trigonometry that you're exposed to at this level of maths. Later on, things might change, you never know. But right now, that is one of your fundamental rules for solving a problem. You need to have a 90 degree in that triangle. Otherwise, sorry, you cannot use trigonometry. So this is when I say that the likes of maths is actually much like a language. You need to learn the rules of the language before you can speak the language. You need to know your is's and your r's if you're going to be speaking plurals and singulars in English. Just much the same, if you're going to be doing Pythagoras and trigonometry, you need to know your rules. SOHCAHTOA, your special angles, 30, 45, and 60-degree angles. These are important rules to learn when you're doing trigonometry. So let's redraw our triangle. We've created a triangle on this Cartesian plane by dropping down a dropper, which meets at 90 degrees along the x-axis. You then get your y, your x along the x-axis, and your r that meets from the origin to point P. We can easily label this as line OP, as was mentioned in the question. And we have our x value being -3, which we get from the point P. It's the first coordinates -3, and your second coordinates would be 4, so that's your y value. So as you can see, we're no longer really using the opposite, adjacent, and hypotenuse. If you've been following the videos, you'll get what I'm saying there. In this case, we'll be using the x, y, and r. However, they're not anything different. They're all the same, it's just a different way of labeling. And because we're using a set of axes, it actually makes it a hell of a lot easier to understand which value is x, which value is y, and which value is r. Now, in step 2, we'll be tackling Pythagoras. Pythagoras works on a right-angled triangle, which is a 90-degree triangle. So you need to make sure, once again, 90 degrees is paramount of importance. So you've got r squared is equal to x squared plus y squared. We can plug our values in straight away. We put in brackets -3 and we square it, we get 9. We put 4 in brackets and we square it, we get 16. We add these two values together, what do we get? We get 25. The square root of r squared is r, and the square root of 25 is, remember from previous videos, if you've been following, it's plus or minus 5. That is very important to take note of. But something to take note of as well is that the r value, your radius, it comes from the radius of a circle, right? It's always going to be positive. That is very, very important. Just remember that. Like, put that into your memory bank. Never forget that. That is super, super, super important. So you never waste time wondering whether, okay, is this a minus or is this a plus? Radius is always positive. That is a fact. It's never going to change. It comes from, as I've mentioned, a circle. If you start in the middle of a circle, you go out towards the circumference, that's always a positive displacement or distance in this particular case. And there we go. Remember that, keep it in mind. If you need to make a serious note about that, draw a circle and just try and figure it out. Can you ever get a radius that is negative? And to be perfectly frank, it's actually impossible. If you are finding that these videos are going too quickly, please make sure to visit thinkbrainwave.com, where you'll find a full list of videos, notes, and tests. You can go and check these things out. It's free at the moment whilst we're in beta phase. Later on, this video is being launched in 2019. In a few months or maybe a year or two, we will start charging a subscription fee. So get in early, get your free videos, and learn as much as you can while you can. When we do launch, it's not going to be very expensive. It'll be something like 100 Rand or maybe $10 a month to sign up. And there you'll have access to unlimited videos, unlimited notes, and unlimited tests. So you can actually see where you are going right or going wrong. So now that we've done that, let's move on to step 3. What do you think step 3 is all about? Take a guess and try and move forward. If you can't, stick through the video. If it's your first time watching, that's fine. But if you're watching it for the second or third time, it's a good thing to go and try and work ahead and see if I can catch up to you. So we have x is equal to -3. We have y is equal to, what was it equal to? Can you remember? It was 4. So now we've got r is equal to 5. What do you think we're trying to look for? Okay, so just check out from the beginning of the question, we need x, y, and r. So I'm going to leave you here. Check out the next video and see where we go. Easy game.